This is problem 5 from chapter 15 of the textbook Stats Modeling the World. The authors are BVD. So what we have here is another probability situation where it looks like we're looking at dorm rooms at a large college, and we're looking at the probability that a room would have a refrigerator and the probability that a room would have a TV. So let's just look at the given here and kind of define some variables. So we're told that the probability of a refrigerator, so let's use R, is 0.38, and the probability of a television, a TV, is 0.52. Okay, and let's see. And the probability that they had both. So the probability of a refrigerator and a TV is 0.21. Okay, so one of the tools that we have, we always want to make a picture if we can. In this case, the picture is very useful to us. So let's make what we call a Venn diagram. So this is supposed to be a rectangle, so pardon the wobbly lines. And so let's draw a circle to represent the probability of having a TV. Okay, and that would be 0.52. And then let's draw the probability of having a refrigerator. Okay, so what we know is that there is overlap. So there's a probability of having both, and that's 0.21. So this remaining area right here would be 52, right? It would be 0.52 minus 0.21. So what's that going to be? 0.31. 0.31. And over here, probability of a refrigerator, that's 0.38 minus 0.21. So that's going to be 0.17. So typically you don't show the computations in the Venn diagram, but I wanted to do that. So now if we added them all up, 0.31, 0.21, and 0.17, we're going to get 9 and 0.69. So 1 minus 0.69 is equal to 0.31 as well. So this is the probability of having neither a TV or a refrigerator in a dorm room. Okay, now that we have what's called a Venn diagram of the situation, it might be easy to answer these questions just by using a diagram. So the first thing, what's the probability of a TV but no fridge? Okay, well, let's see. A probability of a TV but no fridge, that would be right here, right? This is the probability of a TV, but this little area is a TV and a fridge, so we take that out. So it's 0.31. 0.31 or 31%. Okay, that's how I'm going to do this problem. Since I worked so hard to make the diagram, I'm just going to exploit it. Now maybe I can say by diagram. So they know where I'm getting my information. Let's see, what's the probability of a TV or a fridge but not both? Well, let's see. Here's the probability of a TV, but no fridge. So it's going to be 0.31 plus, what's the probability of just a fridge but no TV? 0.17. Okay, so that looks like that's going to be about, is that 50%? 48. Yeah, 0.48 or 48%. Okay, so that's how I do that one. Now let's look at the, and again, I might want to say, just to make sure I get full credit, by Venn diagram. Okay, just documenting where I'm getting the information. This, you can't do this if you don't have the diagram, but if you invest in the diagram, then this is okay for the AP test. Okay, here now we want the probability of neither a TV nor a fridge. Maybe I think I need to put an E on this. I'm not sure. I don't write fridge very much. Okay, so let's see. That we've already done because this is neither right here, right? This is TV, fridge. So it's just going to be 0.31 to be formal, or 31%. Okay, so depending on the problem, we might want to write out a sentence. But since we've used this notation that's readable, we can kind of forego that. But if you used a notation that was very symbolic and not necessarily easy to read, then you would want to write a sentence to answer the question. Okay, so that's how we do this problem. I hope that helps. Again, make a picture, make a picture, make a picture.